Hello class again, and welcome to this particular video. And in here we're going to continue from where we stopped, where we're going to be looking now at systems of equations instead of looking at graphing used to determine the point of intersect. And in here there are two ways of going about system of equations. One way is by substitution and the other method is by elimination. But for this particular course we'll be looking mainly at examples dealing with substitution technique. And in here, when you're given two equations, which is presented as this, equation 1 has m1 b1 and equation 2 has m2 b2, what we have to consider in substitution technique first is to combine both equations together. And once you do that, you will be able to find one specific variable. In this case, I have to put in y on the other equation and then actually solve for x, and by doing that I am able to determine what the x of that particular point of intersect is when I have to subtract b1 from b2 and divide your answer by the subtraction of m2 from m1. And once you do that, you're able to determine what x is. And once x is determined, what you have to do is put x either in equation 1 or equation 2. But in this case, we're going to put it in equation 1, and by so doing, you'll be able to find the y, which is the outcome of that particular intersect. So that particular point of intersect is actually giving us the y value, which is represented as m1 multiplied by everything inside the bracket plus b1. And if you want to get back your original equation, all you have to do is just sub in your x, which is given in there, and you'll be able to get your original equation. So the big takeaway here is I'm able to determine what the x and the y is for that particular point of intersect. Now the other technique is by elimination, which in here is not really too complicated. All you have to do is to express both equations picking one variable that has coefficients that is actually the same. So if you have the coefficient of a specific variable that is the same, then you subtract, and by so doing you'll be able to determine or make one of the variable. You must make one of the variable to be equal to 0, and once you have that, the other variable you have to solve for that, and what you get is the x, which is not coincident, it is actually true. It means here that whatever you do in the by substitution or by elimination, you will get the same x no matter what. And once you find the x for that elimination, which is the same as the substitution technique, you actually put your x value either in equation 1 or equation 2. In this case, we're going to put it in equation 1, and what we get is our y, and our y is indeed the same expression as that of the substitution technique, and this actually gives us the y of that specific point of intersect. And in this particular elimination technique, if you want to get back that original expression in terms of 0, what we have to do in this case is you put in this particular expression gotten from equation 1 when rearranged, and once you're able to do that and rearrange all the equations, you will arrive at 0 is equal to the rest of that particular expression right there. So the big takeaway message here is that either you do substitution or elimination technique, you will always get the x and the y that is actually where the point of intersect occurs. And so in this particular point, what we see is that both x expression and the y are the same. And in here, once we actually perform substitution technique or elimination in both equations, we will on the graph identify the x, which is expressed as b2 minus b1 divided by m1 minus m2, and identify the y, which is equal to m1 all multiplied by b2 minus b1 divided by m1 minus m2 all bracket close plus b1. So that's about it for this particular video. Hope you're able to actually understand this. Ignore the elimination technique we're going to focus mainly on substitution in the next videos or in the next steps that we're going to dive into for this particular course. All the same, stay smart and believe in yourselves.